Hello everyone, I'm Xiangyu, and I'm taking this video to tell you the solutions of the questions in my first homework. So let's begin. Here are the two questions we have to figure out. The first one, we have prove or disprove that formula for any arbitrary events A, B, and C, where the probability of C is larger than 0. First of all, I want to emphasize a very important deduction from the three axiom. That is, the probability of A union B equals the probability of A plus the probability of B and minus the probability of A intersection B. Let's put this item to the other side. Then we get this formula and formula 1. According to the conditional probability, the left side of this question equals probability of A union B intersection C, lower probability of C. And we place another atom to it. That is the probability of A union B union C, lower probability of C. According to the formula 1, we get the same denominator, so we add the numerator first. So then we get the probability of A union B plus the probability of C, lower probability of C. That is 1 plus probability of A union B plus, lower probability of C, which is no less than 1, because the first axiom that probability of A union B is no less than 0. Then we know the probability of A union B intersection C, lower probability of C, which is the probability of A union B given C is no less than 1 minus probability of A union B union C, lower probability of C. It equals this format. So till now we have proved that this formula in this question is correct. Next, let's figure out the second one. Given the probability of A is larger than 0 and less than 1, and the same to the probability of B. So we know that it's same to the probability of A complement, that is, and the probability of B complement is also larger than 0 and less than 1. Then the formula says, let's prove the probability of A given B plus the probability of A complement given B complement equals 1 if and only if A and B are independent. So we can note that IFF means if and only if. So it's apparently it's biconditional. So that means we have to prove this formula from both directions. First, let's prove its sufficiency. The probability of A given B plus the probability of A complement given B complement. It equals probability of A intersection B, lower probability of B, plus the probability of A complement intersection B complement, lower probability of B complement equals 1. Right? So how can we prove that A and B are independent? I've think about it for a long time, and finally I think I got away from this formula again. So I make the first item minus probability A product probability of B, and do the same operation to the second item. To make the formula to make the left side equals the right side, we have to minus the same operator, that 1 minus probability of A minus probability of A complement. look what we get. It's 0, right? So let's make it the formula 2. Okay. Then let's product both sides with probability B and probability of B a complement. So we get probability of, so we get this formula, right? Since we consider that event B and event B complement are mutually exclusive, so to make this equation correct, we have to make the probability of A intersection B equals probability of A, probability of B, and also probability of A a complement intersection B a complement equals probability of A complement product probability of B a complement. So from these two equations, we can get that A and B are independent. Then we also have to prove the necessity of this formula. So it's easy. If A and B are independent, we got the probability of A given B plus the probability of A a complement given B a complement. It equals, because A and B are independent, so it equals probability of A product probability of B, lower probability of B. That's probability A, right? And the second item is probability of A complement. Apparently, it equals to 1. So we also prove its necessity. Till now, we have figured out the two questions. Thank you. Goodbye.